Welcome back to your favorite intermediate algebra course. We're going to look at graphing and classifying conics, and that's our objective to do this, to go ahead and graph and classify some conics, except we're going to have the vertex in the center is going to be a little different rather than always being at the origin. Okay, so if you're looking at this here, your HK is your vertex for the parabola, and it's the center of those other conics. Okay, so again, we're going to finally move this center or vertex around a little bit, okay, and translate these things. So we'll come back to this. Let's look at the first example here. Writing an equation of a translated parabola. So we're going to write an equation of the parabola whose vertex, whose vertex is at 1, -3. Let's kind of make this picture here. So we got this vertex at 1, -3 right here. And the focus is at 1, -4. Let me put the focus in green here. Now, if you remember with these parabolas, you're wrapping around your focus, aren't you? Okay, so you're thinking to yourself, well, this parabola, now before when we did it, if it opened down, it was of the form x squared equals 4py, okay, where p was this distance right there. It was p distance away, and then we had this directrix up above it, okay, so if you recall that. So x squared equals 4py, that means it opens up or down. Now, and we knew it opened up if our p was positive, and it opened down if our p was negative. Okay, so we know here our p must be negative. Our p must be negative because it opens down. Okay, so we're going to kind of make this a note for ourselves because we're gonna write this equation. Now, we've moved this off of the center, obviously. You know, our new vertex here is at 1, -3. Okay. So if 1, -3 is our new vertex, that's our HK, okay? So this equation, if you go back right here, for this is right here, we got this vertical axis, x minus h quantity squared equals 4p times y minus k. So again, instead of this one, we're moving that HK, that vertex, around. Okay, so what's our H? Well, our H is 1. P we don't know yet. We got to find our P. We do know our K is -3, so it looks like we got that Y plus 3 right there. Okay, so now we got to solve for P. So that's the question. Let's go to the side here. Let's solve for P. Now we know this thing opens down. So we know our P must be negative. And P is, again, that distance between the vertex and the focus. And this one's really easy because it goes from that 1, -3 to 1, -4. So you know that P, that P distance here is 1, going from -3 down 1 to -4. And since it's negative, P must be -1. Okay, so that's what we're going to plug in right here. You plug that -1 in for P. Okay, and now we're going to have our equation. X minus 1 quantity squared equals 4 times P times Y plus 3. So x minus 1 quantity squared equals -4 times Y plus 3. Okay, and that's the equation for that parabola that had that vertical axis there. Okay. All right, let's move on here. Let's graph the equation of a translated circle. Okay, so for a circle, before it was x squared plus y squared equals r squared. Now they're giving us the equation this time. Except we have a new center for this thing. Okay, so if we're going to graph this thing, we need to identify where is this new center? Where is HK? Our new center is at HK. And of course, we know our radius here. our radius, r squared, is 4. So we know our radius must be 2. Okay, we just got to find this center. So let's look at this thing. What would h have to be if you got x plus 1 and an x minus h? Well, h must be negative 1. Another way to think about this isn't x minus a negative 1 really x plus 1? So our h, is the h is the value right after the minus sign, right? So h is negative 1, comma, what would our k be? Well, maybe let's rewrite that y plus 2 as y minus a negative 2 so we don't mess up. So we don't mess up identifying our k. So our k must be negative 2. Okay? So we got this center, negative 1, negative 2, and now we just go from there. We go perfectly to the right, 1, 2. Okay, that's going to be on the circle, perfectly up, 2, vertically, perfectly to the left of our center, 2, and perfectly down, 2, and then we can draw our nasty looking circle. Whoops, I totally missed that point. But anyways, the center of that thing's at negative 1, negative 2, and our radius is 2. Okay, so that's how you graph an equation if you have a translated circle. All right, how about writing an equation of an ellipse with a foci at negative 1, 0, and 3, 0. Let's start there. And of course, you got your vertices there. In fact, you know what? I'm going to start with my vertices first. Start with those vertices. Try and make this thing visual is what I prefer anyway. So negative 3, 0, 5, 0. So you can tell how already we're just a little off from the center, aren't we? Because we know the center of this thing is not going to be right in the middle. Okay. So there's our vertices for this thing. And we got these foci at negative 1, 0. Let me put my foci in green here. Negative 1, 0, and 3, 0. Okay, so this thing kind of looks, it's going to look something like this, right? Our ellipse. So our axis, our major axis is horizontal. So before, when our major axis was horizontal, we had this equation, x squared over a squared plus y squared over b squared was equal to 1, if you remember that, okay, and a was bigger than b, okay. This is kind of similar, except again, we've moved it off of the center. So now, instead of that, you have this x minus h squared over a squared plus y minus k, because again, we've moved it hk over b squared equals 1. So that's what I'm thinking about. So I'm going back, and that's just right here on the ellipse. Major axis is horizontal, right there. Okay. So we're moving this thing hk around. All right, let me go back to problem there. All right, so the question becomes, well, sorry about that. We need h, we need k, so we need our center of this thing, right? And then we need our A and we need our B. So the center of this thing is going to be halfway between our foci, or if you want, if you will, halfway between our vertices. So find the center HK of this thing. So that is the midpoint between, you could do between the vertices, or you could do the midpoint between the foci. It really doesn't matter. You know, let me use the vertices. Okay, so we got negative 3, 0, and 5, 0. So if you remember the midpoint formula, midpoint is x1 plus x2 over 2, comma, y1 plus y2 over 2. And I know you can just count it off on this one, but I'm going to have you, make sure that you can also use a midpoint formula just in case it's easier for you. It's a different problem, or in case you have really vertices that are very far away type of deal. A lot of distance between them. Alright, there's our center of this thing. There's our center. There's our HK. Let me go back up to this. So we got 1, 0. We're like, oh yeah, that makes sense. 1, 0. That is right between those foci, right in between those vertices. Okay. So now we know HK is 1, 0. And from there, let's start writing this. We do need one more thing. We have our A. A is the distance to a vertex from the center. So let's count it. 1, 2, 3, 4. So A is 4. Okay. Now we do not know B yet. Okay, this is distance B. So we're going to have to figure that out. So we've already found the center HK, so we can plug that into the equation. We need to find B. So how are we going to do that? Well, we'll use that formula that we had for ellipses. So we find B. So C squared is A squared minus B squared for ellipses. Okay. Now the question is, well, what's our C? First of all, our C is our distance from our center to our foci. So let's see how that C is a distance of 2 there. So C is 2. We already talked about the A. The A was 4. Now we got to find the B. Okay, so 4, 16 minus B squared. Subtract 16 both sides. 5 by negative 1. B squared equals 12. So B is the square root of 12. Okay. All right, so let's go down a little bit here. So now what do we know? Okay, well, the first thing is we found our center. Second thing is we had to find our B after identifying the A and the C distances. So 3, let's put it all together into this formula. X minus H quantity squared over A squared plus Y minus K quantity squared over B squared equals 1. And let's plug in. We know HK. 1, 0 is our H and our K. We also know B is root 12, and we also know our A was 4. Okay, those three things, we know those 3 things. And that's all we need. X minus H is 1. A is 4, so we got 4 squared on the bottom there, so 16. Y minus K, so Y minus our K is 0. And our B was square root of 12. Of course, square root of 12 is going to be squared. It's equal to 1. So we had X minus 1 squared over 16 plus Y squared over 12 equals 1. There's our equation. Okay. So that's writing the equation of ellipse with given foci and given vertices here. Okay. Now let's go to hyperbolas. Let's graph the equation of a translated hyperbola here. So, all right, let's think about. Now, typically, when we initially learned hyperbolas, we had this x squared over a squared minus, because if we had the x squared first, then our transverse axis, write this, our transverse axis was horizontal. Okay, so it looked something like this, right? Of course, and our center was just at the origin. So now they've just moved it over HK. So now we're thinking about this one. X minus H quantity squared over A squared minus Y minus K quantity squared over B squared is 1. Okay, so our transverse axis is still horizontal here, but we've moved it off HK. Okay, and we moved the center of this thing off of the origin. Okay, so let's identify first of all the center of this thing. What's our HK? Okay, can you notice that your H value must be 1. It's whatever's after that minus sign. So H is 1. And our K is 1. Okay, so our center here is 1, 1. Let me erase this other one here. Okay, so our center of this thing's 1, 1. All right. Now let's talk about the a. Notice a squared must be 9. So a is 3, square root of 9 there. And a is the distance from the center out to the vertex. And we know the transverse axis is horizontal. So I'm going to go out horizontally 1, 2, 3 units from the center in both directions. 1, 2, 3 units in that direction. Okay? So I know this thing is going to kind of open up to the right and open up to the left here. Okay? Now the other thing is b squared. B squared is 1. B squared is 1, so b is 1. And that b is just helping us to draw that imaginary rectangle. Okay, if I put my dots there, helps me to draw the rectangle so I can have my slant asymptotes. So these slant asymptotes, oops, that's not too great. Kind of help me draw this hyperbola. Okay, so let me see if I can. There's my hyperbola. There's my other hyperbola. Okay, so there it is. There's our hyperbola with a with a transverse axis that's horizontal. We've got the vertices shown there. You know, we got the one vertice over there at 4, 1. We got the other one at -2, 1, and with the new center there at 1, 1. Okay? So that is graphing equation for a translated hyperbola. Let's move on here. Classifying conics. Okay, now this is a little different than what one of the textbooks that you may have is, but I think a little bit simpler in helping to graph, I'm sorry, to classify conics, okay? So let's look at this first one, A. Classify the following conics. X squared plus y squared minus 2x plus 4y minus 11 equals 0. Okay, so what we need to do is identify our A, B, C, D, E, and F. So remember, this is ax squared. I'm just rewriting this general form here, plus bxy plus cy squared plus dx plus ey plus f, that equals 0. Okay, so let's identify, first of all, a. You see how a is 1. Okay, so a is 1. And what we need to know, you notice on each of these, we need to know a and c and how they're related. Okay, so I'm looking for a and I'm looking for c, and that's really all I need to, for now, what I need to know to figure this thing out. Okay, so you notice a is the coefficient of x squared, so a is 1. Okay, and what's c? Well, I'm looking for the y squared term. What's the c? Well, there's the y squared term. What's the coefficient in front? C is 1. Okay, so a is 1 and c is 1. Now, so you're probably looking at this number 1 and you're thinking, well, a circle is when a equals c. But notice, but you can also think about, well, what if I multiply the two? You know, if I multiply 1 times 1, does it give me 0? No, so it's not a parabola. If I multiply 1 times 1, is that positive? And you're like, sure. They have like signs. But you always go with, if you have A being exactly equaling C, even though they're positive, it's going to end up giving you a circle here. Okay, so if they're exactly the same and A does not equal 0, okay, then you can just say that they're a circle. Okay? So if A equals C, A is not equal 0, you say, I have a circle. Okay? All right, next part here. Y squared minus 18x plus 84. Okay? So we're looking for A. First of all, what is A? Well, A is the coefficient, again, of our x squared, right? A is the coefficient of x squared. You notice down here, there's no x squared. So A must be 0. Okay? 0x squared would clear that out. So A is 0. Now you're looking for C. Well, you see the c is the coefficient of the y squared. C is 1. C is 1. Okay, so let's go through them. Number 1, does A equal C? Is it a circle? No, they're different. Number 2, does A times C give you 0? Extend this. Does A times C give you 0? Sure. 0 times 1. Doesn't that give you 0? Right? It does have a condition on that. A can be 0 or C equals 0, but both of them cannot be. So you're like, aha, only one of them is. So this definitely fits being a parabola. This is a parabola. Okay? So that's kind of how you classify conics. Now, if you're good enough with that, just identifying A and C, then you can probably stop right there. If you want to, I am going to show you how that you can just complete the square and you could identify by the type of equation that it is, right? What it is. In fact, let me take that x squared, let me take this first one. X squared plus y squared minus 2x plus 4y minus 11. X squared plus y squared, good grief, I already forgot it. Minus 2x plus 4y minus 11 equals 0. X squared plus y. Make sure I got the right equation here. Okay, so if you're going to take a look at this and actually complete the square to put it in the form, what you want to do is you want to take your x squared, your minus 2x, kind of put those together for a minute, okay? And then take your y squared and that 4y, okay, together for a minute, and then throw that 11 to the other side. So add 11 here, add 11 here. Okay, and think about completing the square twice, if you will. Okay, so at this point I say, well, let me complete the square on this, and let me take this b term, so that negative 2 over 2, and square that, so that's negative 1 squared, and I'm going to add that in. Negative 1 squared is 1. Okay, so I'm adding 1 to the left-hand side. I got to add 1 to the left-hand side over there. And then you notice this will be x minus 1 times another x minus 1. So x minus 1 quantity square. So I just completed the square on that one. Now let me look over here. You got the 4, right? So you got the 4 over 2. You take that b term over 2 and you square it, and that's what you need to add in. So you got 4 over 2 is 2. 2 squared is 4. So I got to add 4 to this other side. Okay. So this becomes plus, and then you factor that y squared plus 4y plus 4, and that factors into y plus 2, y plus 2, or y plus 2 quantity squared. And this equals 11 plus 1 plus 4, that ends up being 16. Okay? So you're like, oh, yeah, that makes sense. What kind of an equation is this? X minus h quantity squared plus y minus k quantity squared equals r squared. That means I have a circle. This is a circle where my HK, my center of this thing, center, good grief, oh, that's gonna drive me nuts. My center is at HK, so my center is at HK, and my radius, r squared equals 16, so my radius is 4. Okay, but that's the equation of my circle. So you can complete the square on this if you don't want to look at the little cheat sheet there using A and C. All right, see you guys in class. Bring your questions.